Today's lesson we are going to be rewriting equations and formulas. So after this lesson, you should be able to say that you can rewrite equations to solve for one variable in terms of the other variables. It's going to seem a little weird. Your solutions are not going to be x equals 7, for example. Instead, it might be x equals 7y plus 3. So you're going to still have variables in your solution, and it's going to be beneficial to us when we go to graph linear equations, and it's also beneficial in other applications as well, such as in the sciences, dealing with formulas and having to solve for a certain variable or a certain unknown when you're dealing with some different science applications. So to begin, we have this definition of a literal equation. A literal equation is an equation that has two or more variables. For example, you can see numbers 1, 2, and 3 have two or more variables. So in this case, these first three examples have two variables. So in number 1, it says, we are going to solve the equation for y. And this leads us into, like I said, solving linear equations in order to graph. All three of these are linear equations. We'll talk more about that as the year progresses. But basically, when we graph them, they're going to make a line. And solving for y will help us easily graph that line. So we're going to understand the process for how to do that now, and then we'll apply the graphing part later. So to get the y by itself, I sometimes like to highlight or maybe color that variable that I want to get by itself. So today I'll box it around, and I need to think, okay, I'm getting the y by itself. How would I normally do that? Well, I normally think of my inverse operations or my order of operations backwards, and I do those inverse operations in order to get it by itself. So remember, we always have that negative 3 is timesing by that y, and we have a negative 2x. So I want to get rid of that negative 2x first, just like how we solved our two-step problems before. We got rid of any addition or subtraction first, and then we did any multiply or divide. So in the inverse to subtracting 2x is going to be adding 2x to both sides. And this is where it might get a little weird, or seem a little weird, I should say, because 6 and 2x are not like terms. The 6 doesn't have the x variable with it, so it's like our pennies, and the 2x are like our pouches. They're not the same thing, so I can't actually combine them. I'm just going to leave it as 2x plus 6. And then I'm identifying my variable there that I need to get by itself, which is y, and I'm timesing it by negative 3. So just like before, the inverse to timesing by negative 3 is dividing by negative 3. When I divide or break things apart, I want to divide everything by that number. So negative 3 divided by negative 3 is 1. And then I'm left with my y, or 1y, equals 2 divided by negative 3. Well, negative 3 does not go into 2 evenly, so I'm going to leave it like a fraction. And usually we write that negative sign out front. And then my last part is that we have 6 divided by negative 3, which 3 goes into 6 2 times, so in this case it'd be negative 2. Like I said at the beginning, it may seem weird, but you're actually done here. It has a variable still in the answer, but we are done because we have y all by itself. So we have y equals. We're done, we get to move on. Let's try another one together before you try one out on your own, unless you're feeling pretty confident. So in number 2, again, we have that y that we're solving for. And again, I have a 4x. This time I'm adding 4x because it's a positive 4x. So instead of adding it, I'm going to subtract it. Again, like the other time, these are not like terms, so I'm not actually going to add them. I like to write my x term first, and that'll be helpful for us later when we go to graph it, but you don't have to. You could write negative 5 minus 4x, and that would be the same. And then I'm going to look here, and I'm going to go, okay, well, this one right here, I'm timesing by 1/3, So I need to do the inverse operation, which would be to divide by 1/3 or multiply by the reciprocal. I'm going to jump right to the multiply by the reciprocal. When I multiply, just like when I divide, I need to multiply everything by there. So 3 divided by 3 is 1. I'm left with just y on that side. And then over here, I have 3 times -4. I can essentially ignore that divide by 1 because it just means that it's going to be a whole number. So -12x, don't forget that x. And then I have -5 times 3 minus 15. And I am all set there. All right, in number 3, go ahead and try that on your own, so pause the video. My hint to you in number 3, though, is to write a little 1 in front of that y, and that will be helpful for you. All right, so I'm going to identify my y again, and I notice that I'm adding 3x. That's a positive 3x. There's no sign out front, so I'm going to subtract 3x. I get -1y equals -3x, and that's a positive 2, so I'm going to write +2. Then I notice, okay, -1 times y, so I need to get rid of that time, so I'm going to divide everything by -1. I get y equals positive 3x minus 2, or you could write plus -2. The next problems that we're going to look at are application problems that you will see in our class later on in the year, and also anytime in your math or maybe in science class. So the first formula that we're going to look at is the volume formula for cylinders, which we're going to do volume later on in this year, and it is volume equals pi times r squared times h. So the first time that we see it up in the problem, it doesn't have all of those dots in there, but just remember when things are next to each other, that means multiplication. So this time I wrote it just so that we can get a good visual of what's going on. Don't be concerned with that r squared. I know we haven't talked about exponents at all in class yet, but exponents just mean that we are multiplying the same thing by itself. So in this case, we are multiplying r by itself twice, since the exponent is 2. So it's just another kind of multiplication. So really I'm multiplying by r, by another r, and by pi. Well, the inverse of multiplying by anything is dividing. And I don't want to divide by it individually, so I want to divide by pi to get rid of that, and I want to also divide by r squared. That way, again, I don't get a messy fraction that I make more complicated than what need to be. So you can multiply or divide by multiple things at the same time. So I get pi is my cross off, and my r squares cross off. So I get my height equals volume divided by pi r squared. All right, let's look at our next one. We have the area of a rectangle equals base times height. So again, this is another multiplication problem that we have to undo the multiplication with. So the inverse to multiplying by our base is dividing by our base. So we get height equals the area divided by the base. So this is real easy. The reason why we solve for specific variables is to be able to do multiple problems where maybe I know the area and the base and I want to know the height of the rectangle. And I know that you guys were recently doing formulas like this in science class as well, where you had, I don't know if it was the distance or the mass. I don't remember the exact formula, but I remember seeing it up on the board in your science class where you were solving for a specific variable and you had to use that variable to do, or use that formula to do multiple problems. In our last problem, we have a simple interest problem. So this says interest equals P, which stands for principal, times R, which is rate, times time. So when you have a simple interest, you take the amount that you originally put into the account, times it by your rate of interest, and times it by however long that you keep it into that account. And that's how much interest that you gain from that money that was accruing the interest. So in order to solve for the principal, which is the P, we need to undo the multiplying times r and t. So instead of dividing or multiplying by rate times time, we're going to divide by rate and time. So then I get P equals my interest divided by my rate and my time. And I'm all set. I can easily use that formula to be able to find my principal. Be sure to write 2 to 3 sentences on how to solve literal equations. Of those 2 to 3 sentences, you could include one sentence where if you are confused on something. And also don't forget to solve, we're going to do the distance formula, solve for t, which is time.